Next subtopic is 6.2 Centripetal Force, where in this subtopic, we're going to define centripetal acceleration and solve problems related to centripetal force for uniform circular motion cases of horizontal and vertical. Centripetal force. Okay, first part in centripetal force is centripetal acceleration is defined as acceleration moving in a circular path and it directed towards the center of the circle. When an object moves in a circle, we know that even the speed does not change, but because of direction change, so we're going to have a centripetal acceleration. Magnitude of centripetal acceleration of AC, so your centripetal acceleration equals to V squared over R, where your V squared is speed of object and R is the radius of your circle. So when you have object move in a circle, so here the radius of the object. Since V equals to R omega, your centripetal acceleration can also be written as R omega squared or V omega. Example, when we have our centripetal acceleration equals to V squared over R, so V is R omega squared over R. This will give you R squared omega squared over R. R you can cancel out, which will give you R omega squared. And because V equals to R omega, so this formula R omega squared can also be written as V omega. So you have R omega times with omega, which is equals to V omega. Unit for centripetal acceleration is meter per second squared. Centripetal force is defined as the net force required to keep an object to move in a circular path. So, force that required for an object to move in a circular path. Example, as the moon orbits the earth, the force of gravity acts upon the move, providing a centripetal force. Gravitational force is equals to the centripetal force that able the moon to orbit the earth in a circular motion. Or as a car makes a turn, force of friction acting upon the turn wheel of the car that provides the centripetal force required for circular motion. Magnitude of centripetal force. So now centripetal force based on general formula of force equals to ma. So for centripetal force, where we have this Fc here, equals to m mass times centripetal acceleration, or centripetal acceleration equals to v squared over r. So our centripetal force equals to mv squared over r. You can relate centripetal force with omega as well. Rearrange the equation, you will get mr omega squared or mv omega. Direction of centripetal force is always towards the center because centripetal force is related with the force that makes the object move in a circle. So the centripetal force direction always towards the center. Doesn't matter where your object is. Because centripetal force is perpendicular to V, so it does no work on the object. So your work because of centripetal force equals to 0. Unit for force as with normal force, gravitational force and all those forces, the unit for centripetal force equals to Newton N. Circular motion in horizontal plane. As I mentioned before, circular motion we have two parts, horizontal plane and vertical plane. First case, for horizontal plane is object move in a horizontal circle with a steady speed. Now this object, it will exert two different forces. First is tension and second is weight. Two forces acting on the object, weight downward, and the tension is the only component in radial direction that provided the centripetal force. Applying Newton's second law, we have two components here where we have Fx, which is equals to our centripetal force equals to MAC. So this centripetal force, now you relate with the diagram. What is the force that supply forces towards the center? What is the force that supply force towards center? So based on the diagram, force that supply force towards center is tension. So here, our centripetal force is equals to the tension, which is equals to mv squared over r. Second case, motion of a car round a curve or a flat curve road, where from this case here, the coefficient of static friction between the tire and the road is Fs equals to mu sr, or your frictional force is mu times with n, mu n. Mu times r, same thing. The friction supply the centripetal force. Again, centripetal force related with force towards center. Based on this diagram here, you know that there are component y and x involved. So for component y, your summation of Fy equals to 0 because the car is not flying. So basically, your y component, vertical component equals to 0. From vertical component, you have n and mg. N minus mg equals to 0, which will give you n equals to mg. N equals to your weight. In component x, as we have derived just now, component x related to your centripetal force. Force towards center is equals to your frictional force. So Fs equals to mv squared over r. Formula for frictional force is mu times with your normal force equals to mv squared over r. Now, we have two equations. We're going to substitute n equals to mass times with gravity into our second equation because we need this n here. So, mu s mg equals to mv squared over r. The maximum velocity, when we want to calculate this v here, so the maximum velocity without slipping is equals to mu rg square root. Case 3, conical pendulum. Conical pendulum moving in a uniform circular motion with speed v. Based on the diagram given, so from here, when we have angle, and we resolve into x and y component, force towards the center is given by t sine theta. How to calculate your r? When you are given length of string, you can use Pythagoras theorem, where you have this is your length of string and angle. So how to calculate for radius? So this is where your r is, the radius of your circular motion. R is equals to L sine theta. Based on the diagram, also for this case, you have two components, component x and y. For component x, regarding your centripetal force, now your centripetal force is t sine theta equals to mv squared over r, first equation. Component y, you have here component y. So, summation of Fy equals to 0. It does not move vertically. So, summation of Fy equals to 0, where you have your t cos theta equals to mg. Okay. Now, you have two equations. How can you relate between these two? When you divide first equation with second equation, t sine theta divide with t cos theta, can cancel out here. Sin theta over cos theta will give you a tangent theta. Then m and m you cancel out. So you will have equation of tangent theta equals to v squared over rg. So how to calculate for your velocity in circular motion for pendulum case? V equals to sec rg tan theta. Or you have this one more formula of lg sin theta tan theta depending on the informations that you have. Okay. Next case is circular motion in vertical plane, where for vertical plane, we're going to look at two different positions. One is at the top of the circle and one more is at the bottom of the circle. So let's look at on the top of the circle first. So because this is a vertical plane, example Ferris wheel, as the object move vertically, so we're going to look at centripetal force in y-axis, in y component. So in y component, okay, how to write your centripetal force? Now, because at the top, your centripetal force is always directed towards the center, which is downward. So what do you have to do is your downward force minus with upward force. That's why you will have mg minus n equals to centripetal force mv squared over r. So from here, when you rearrange your equation, it will be n equals to mg minus mv squared over r. Your n is the normal force. Compared with bottom of the circle, so on the bottom of the circle here, object is at the bottom, then your centripetal force is directed upwards. To choose which force minus which force, because the direction of centripetal force is upward, so we're going to choose upward force minus downward force. And minus mg equals to mv squared over r. So, normal force at the bottom of the circle equals to mv squared over r plus mg. So, that's all for today. Lesson 6 covered the whole chapter 6, 6.1, 6.2. Next week, you will start with chapter 7. Thank you.